Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 10, Lesson Number 2, on quartiles and box plots. Alright, before we begin, let me remind you that you can find a worksheet and a homework assignment that go along with this video by clicking on the video's description, or by visiting our website at www.emathinstruction.com. As well, don't forget about the QR codes at the top of every worksheet. Use your smartphone or your tablet to scan that code, and you will be brought to the video that corresponds to that particular lesson. All right, let's begin. In the last lesson, we took a look at how data sets were represented by dot plots and by histograms. Today, we're going to start to get into some actual statistics and into some of the other plots that are used to display the way that a data set distributes, let's say. So, in exercise 1, it says shown below are the scores of 16 students received on a math quiz. All right? And they're written in ascending order, and that's actually kind of important for this problem. The first thing that we're asked is to find the median of the data set, the median. Now, this is actually review. The median would be considered the middlemost data value. All right, now, typically the way students do that is they kind of go in from the middle, from one side and the other side. Now, if a data set has an odd number of data values, it's very clear what the middlemost data value is. But 16 is not odd, it's an even number. So in fact, 1, 2, 3, 4, 5, 6, 7, 8, right here is the middle. So what do we do when we have an even amount? Well, what we then do is we find the average of the two most middle data values. So in this case, the median is 73.5, the median. It's like that line right down the center of the road, right? The median. Again, if we had had 15 data values, there would have been a value right in the middle. But with an even number, we always have to go right there and take the average of the two most values in the middle. Now, letter B asks us to find the range of the data set, defined as the difference between the largest data value and the smallest data value. We've done that before, and it's fairly simple. The range here is going to be a 98 minus a 52, so the range is 46 points. That's a big range on a quiz, 46 points. Whew. Wow. Now, here we're going to start to talk about some terminology that you probably haven't heard of before, what are known as the quartiles. So letter C asks, what is the median of the lower half of this data set, known as the first quartile? All right, so what quartiles do is they literally chop the data set up into quarters. The first quartile, which is often symbolized with a Q and a little 1 down at the bottom, is given by taking a look at the lower half of the data set. Let me circle that in red. And then what we're going to do is we're going to find the median of that. Well, that's also got an even number, so our Q1 is going to be 66 plus 68 divided by 2. So our first quartile is 67. That's the value that cuts off the first 25% of the data from the second 25% of the data. We can also talk about the third quartile, Q3. That's going to be the median of the upper half of the data set. All right, here's my upper half. And again, because it's got 8 values in it, right, our Q3 is going to be right there. So it's going to be the average of 82 and 84, which will give me 83. So 83, if you will, sort of divides the upper 25% from the sort of third 25%. You might actually wonder to yourself, where did Q2 go? Where is the second quartile? Well, the second quartile is the median, right? It's the one that's right in the middle. So the idea is, you got all this data, right? All these data, right? And you cut them up, right? You cut them up with the median, the first quartile, with the third quartile, right? Anyway, that's not very well represented. I should have another X here. Okay, so that's it. But the quartiles are a little bit tricky. You know, it's like dividing a pizza into quarters. Divide it in half with the median, and then take each of those halves and divide those in half as well. And those are our quartiles. Okay? So I'm going to clear out the text. You write down what you need to. All right, here we go. Now, those numbers give rise to something called a box plot. All right? Box plots go by a couple different names. That's the technical Common Core name. What we're going to see as well is that they're also called box and whiskers diagrams, and I'll explain that kind of cool name. The name you really want to know is box plot, but I wouldn't be surprised if you see box and whiskers as well. I got so used to calling them box and whiskers that it shows up in this lesson a little bit more. Now here's how you make a box and whiskers plot, also known as a box plot. Okay, you take your minimum value, which is equal to 52. You take your first quartile value, which is equal to 67. Well, I almost said Q2, but let me stick with, whoops, that didn't work. I like the fact that I'm back in black here. You take your median, that was 73.5. Your third quartile, 83, and your maximum value, 98. And you show how they distribute along this number line. Now notice the number line is not plotted. Sometimes they're plotted, labeled. Let me say labeled. I shouldn't say plotted. Sometimes they're labeled, sometimes they're not. Worst case scenario is that they're not labeled. So let's think about how much we should make these go by. If we make them go by ones, it's going to be too small. Okay, so let's see. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've got 14 spaces. And in those 14 spaces, I've got to fit in a range of 46. So if I take 46 and I divide it by 14, what do I come up with? Let me grab my calculator. 46, whoops, that didn't work. 46 divided by 14. It gives me a little bit more than 3.28. Now that's ideal. I'd go by 3.28 and I would confuse the living daylights out of people. I don't want to do that. Let's not go by threes. If you can, go by ones. If you can't go by ones, go by twos. If you can't go by twos, go by fives. If you can't go by fives, go by tens, etc. Right? So what I'm going to do is I'm going to go by fives. I'm going to actually start at 50, and then I'll make that 60, I'll make that 70, I'll make that 80, I'll make that 90, and I'll make that 100. And yeah, there's a number line that I'm not going to use up here, but that's okay. So here's what I'm now going to do. I'm going to put little vertical lines. All right, 52 is right about there. All right, 67 is right about there. All right, 73.5 right about there. 83 right about there. And 98 right about up there. Then I'm going to put a box right here, and I'm going to extend these outward. Now, you'll see box plots drawn in two different ways. You'll see them drawn like this, and you'll also see them drawn without those little things on the end. Okay, and maybe just a dot at the end. This is the way a more traditional box plot is drawn. This is more of the box and whiskers. They show you exactly the same thing though. They show you the minimum value. They show you where the first quarter gets cut off. They show you the median value. They show you where the third quarter gets cut off. And they show you the maximum value. In other words, in a picture, they really kind of show you how the data distributes in terms of its range. Okay? It won't matter which way you draw it, but you should know the terminology, especially box plot. Okay, I'm going to clear this out, so pause the video and write down anything you need to. Okay, here we go. Let's keep going. Sometimes box plots are called box and whiskers diagrams. So again, just to emphasize, box and whiskers, box plot, same thing. Now I could totally see this being confused with a dot plot, right? Primarily because, look at this, dot plot, box plot, it all seems to be the same, but it's not. Anyway, one thing that a box plot and a box and whiskers plot have in common is the word box, so hopefully that'll help. Let's keep going. So exercise 4. The ages of 15 employees of the Red Hook Curry House are given below. Letter A says determine the median and quartile values for this data set. Now again, in order to really get median and quartile values, your data set has to be in ascending or descending order. But the cool thing here is let's figure out the median first. All right. Because there are 15 values, literally it will break down as 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And here's our median. So our median is 26. Now, again, I'm going to go to a different color. We then will use this to figure out our Q1. All right, so Q1, I'll take these 7 and I'll go to its median, right? 3 here, 3 here. So before we had to do all these averages because they were all even numbers. Now we're getting all odd numbers. So there's my Q1. And let's look at that upper half of the data set and its median. And that'll be Q3. All right. Ooh, letter B, create a box and whiskers diagram. And they didn't even give me any number line. So for this, we're going to really free form. Let's draw out a line. Now what do we have? We've got data that goes from 16 up to 44. All right? So, well, actually, maybe I'll go back to this again. What should I make this go by? And that's kind of up to you, but you want to make it so that people can really understand what the distribution is. I don't think I'd go by 1s or 2s. That would mean that we'd have tons of little tick marks along here. But I think 5s makes a lot of sense, right? So maybe I'll start at 15. Maybe I'll then go to 20, 25, and 30, and 35, and 40, and 45, right? Now what we're going to do, and we'll do it in blue, is that smallest value, we're going to plot at 16, right? Then Q1 is going to be at 18. Look at how close that is. Q1 is at 18. You don't have to label these, but I'm showing them. My median is at 26. All right. Q3 is at 37. That's much farther away. And my maximum is at 44. All right. The box is really boxing in the middle 50%, right? The middle 50% is in here. That's a beautiful curve. That's the middle 50%. It's from here to here, right? The lowest 50% then is in here, or sorry, the lowest 25% is in here, and the highest 25% is in there. So there's my box and whiskers diagram, also known as a box plot. Okay? Not too bad. This is what's known as the 5-number summary. The minimum, the maximum, and then that first quartile, the second quartile, but more commonly known as the median, and the third quartile. All right, I'm going to clear this out, so copy down anything you need to. Okay, here it goes. Let's keep going. Now, in exercise 5, they've created my box and whiskers diagram for me, my box plot for me. So 20 of Mr. Ouimet's physics students recently took a quiz. The results of this quiz are shown in the following box and whiskers diagram. Assume that all scores are whole numbers. All right, so how about this? See if you understand a little bit about this at this point. Pause the video and see how many of these questions you can answer, and then we'll go through them all one by one. All right, let's do it. Well, letter A, what was the median score on Mr. Ouimet's, that should have a little apostrophe S, on Mr. Ouimet's math quiz? Well, the median score is given right here. But what is that? Well, these go by twos, right? This is 72, 74, 76, 78. So the median is clearly sitting at 71. It is physics, after all. What was the range of the scores on Mr. Ouimet's physics quiz? Well, we know that the range is the high score minus the low score. So the highest score was 84, and the lowest score was 53. So the range will be 84 minus 53, or 31. Now, letter C was probably the most confusing of them all. What score was greater than or equal to 75% of all other scores on this quiz? Well, that's the third quartile. All right, the third quartile value sits at that 75% mark, and that's right here. Whoops, I just ran through it. That's a 76. Again, it's a physics quiz. It's tough. Letter D, Mr. Ouimet regularly sets the passing grade on his quizzes to be the score of the lower quartile, the first quartile. What is the passing grade on this quiz? Well, that's going to be this one right here, and that is a 64. All right, so this question was all about being able to read a box plot, also known as a box and whiskers diagram. Okay, I'm going to clear this out, so write down what you need to. Okay, here it goes. Let's do one last problem. Exercise 6. Which of the following box plots shows a data set with the greatest median? All right. Now be careful because each one of these has a different scale on it. So pause the video now and try to figure out which one has the greatest median. All right, let's do it. Well, I'm just going to list them out one by one. The median on this one is right here. But watch out, that's a 30, right? Because it's halfway between 20 and 40. On number 2, the median is right here. But that's a 40. These things are going by 10, 10, 20, 30, 40, 50, right? That's a median of 40, so that one's higher. On this one, the median's right here, and that is that's going by 2s, a 22. And here, the median's right here, and that's a 7. So it looks like choice 2 has the greatest median. All right, that's it. So quartiles, medians, etc. Pause the video now, write down what you need to, and then let's finish up the lesson. All right, here it goes. All right, so today we saw quartiles and box plots. Box plots are also known as box and whiskers diagrams. Quartiles are essentially just data values that divide the data set into quarters. The lowest quarter gets divided from the second quarter by Q1, or the lowest quartile, or the first quartile. The median then divides the data set in half. The upper quartile, Q3, divides the upper 25% from the lowest 75%. These numbers, along with the minimum value and the maximum value, then help us to create box plots, which are also known as box and whiskers diagrams. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.